Hello, my name is Piotr Daniczka, and I'm a product owner in Cut Sheet Metal team, and I will show you what we've achieved so far in Raiden Designer for 2020.1. So I will start with unfolding. So I'll just open or drag and drop part from, say, SolidWorks. So that's what we have currently on screen. It is a solid. It doesn't have any sheet metal information. I just say row geometry. So if I go to set part properties, I can select a primary face manually. So let's say I'll pick this one to start with, and right click confirm, and software will automatically apply material unfolding method, and part becomes unfoldable. We can preview how the unfold looks by toggling view. So if I go to set part properties again, this time I'll pick automatic selection. So software now will automatically find best primary face, the most central one. We have 4 unfolding methods: k-factor, setback, din correction, and view width unfolding. So say I want to use k-factor of 0.43, let's say. Just right click and software automatically scans the model to find most appropriate primary face. So I don't have to select it manually. We can also edit bend allowance individually on each bend. So just as an example, let's say I want to have this 3 bends unfolded with a width unfolding method, and say the width value is 20 mil. I can confirm it. So from now on, these 3 bends, they're unfolded using different unfolding methods. So if my unfolding methods have been set, so let's say I've attached different unfolding properties for individual bends, and say if I would like to now change primary face, I can still do that. So I'll pick this one, for example. Software maintains all the unfolding properties on a model. I will now move to edit panel, which contains 4 commands, and I'll start with edit thickness. So if I click edit thickness, I have a checkbox which says read selected part thickness. If this one is checked, and if I click on a model, it loads the actual thickness of the model here into a Docker. So I'm just starting from 1 mil. If I close that, go edit thickness again, and if I uncheck this one and say I want this part to be 2 mil, click on it, it directly applies that value on the model. The interesting bit is that it matters if you click on a model from the outside or from the inside. You can see whenever you hover on it, it just highlights blue outside or inside side. So if I click on the outside, obviously material gets added to the outside. If I click on the inside, material will get added to the inside. But because there is not a lot of space, I will just gradually increase that thickness so you can see what's going on. But once you get to a situation where it cannot do it due to geometric condition, it will just not let you do that. So just to show you what's going on, I will just spread those flanges just as an example. You just spread them apart. So from now on, you will be able to apply thickness to the inside up to a reasonable value. Okay, I'll Control Z this one. Now I will move to bend radius command. So the way it works is it's like that. You still have that selected bend radius concept. So if I have this one selected and if I click on this bend, it automatically loads that value into the Docker. So I'm starting from the actual radius. If I uncheck this one, it will just apply whatever I have here straight away. So that's the difference. I'll Control Z this one, and we have two modes for editing bend radius. I'll try to explain it. Maybe just for an explanation, I'll edit flange angle. So okay, we'll get back to bend radius. So there are two modes. One of them is a virtual axis that basically maintains the position of the flanges and the actual bend moves. So intersection between this flange face and this flange face just stay constant. The other mode is tangent to bend, and it works differently. It maintains the real width of the model. So if I have tangent to bend selected, if I edit that bend radius, you can observe that this bend moves along this edge. That means the distance between this face and a plane parallel to that flange and tangent to this bend, the distance between these two stayed constant, the same, measuring from the bottom to say this face to a parallel plane here. It remains constant. All flange moves, but you can be sure that after editing bend radius, the real width of your model for sharp angles stays the same. Okay, so I will set angle of this flange to 90 degrees again. Now I will move to move flange command. So if I hit move flange, I can pick on a flange and drag and drop it, just pull it left and right. Obviously I can type by how much I want to move it, but I can also use a ruler dimension and drop the measurement from here. So say I want this length to be, say, 80 mil. If I hit OK, from now on, distance between this face and this face is 80 mil. Okay, I'll Control Z this one. If I go move flange again, and I'll pick this one, I can pull it up and down. If I add this flange as well, they will move together. So that's how it works. It is important which flange is selected first. So if I click this one first and then this one, my arrow is attached to the first one selected, which determines the direction of movement. So I have two of them selected, but this one was selected first. I'll do it the other way around. I'll select this one first and then this one. So you can see that that top face have been selected for direction. And obviously I can use a ruler as well if I want to set new height of whatever. From now on the height of it is say 120 mil. Okay, I'll Control Z this one and I will move to edit flange angle. Maybe prior to that I'll just stretch it a little bit, say by 50 mil, so we can see better what's going on. Okay, I'll go to move flange angle. So flange angle command, it is not only important which flange you have selected, but also it is important where you click on the actual flange. So if I click on this flange but closer to this bend, say here, software uses this bend as an axis of rotation. You can see here's the axis of rotation. So the whole model will move like that. So I'll hit escape. If I go edit flange angle and click on this flange but closer to this bend is used to create an axis of rotation. So it is important where on the actual flange where you click. Okay, there are two modes of input. First one is bend axis set as a center of rotation. So as you can see, flange will rotate around this axis. If we go virtual axis, software finds the intersection of this flange's plane and this one. So that's where they intersect, and this axis is used as the center of rotation. I'll hit escape now. And as well as you have two input methods. One is design angle. So you just measure it from the inside. The other one is measured from the outside. So that's how it works. It also has the same read selected flange angle checkbox, which works the same for edit bend radius and edit thickness. So if this one is selected and if I click on this flange, it shows straight away what is the angle of this flange. If I go here again, type in say 90. This is unchecked. If I click on that flange, it just applies 90 degrees straight away. So once we have model like that, I can show you quickly how we can modify that model using existing commands. So we go edit flange angle. I'll type in 45 degrees here. I'll just apply it here and here. So you know this one is horizontal. I will move these two flanges, but this time I'll change direction of the extrusion. So I will just pull it higher, just roughly to the same height. What I can do also now, I can snap to the existing geometry. So whenever I'm pulling that arrow, I can drop it on an existing vertex and it will move to that point. So from now on, I know that this line, top of this flange and this flange, they are flush. What I will do now, I will move this flange, take a measurement from here and say I want it to be 470 wide, for example. I'll hit escape. I'll maybe jump a little bit into the future, but I'll grab this flange and I will drag and drop it up to here. I'll pick this flange, I'll drag and drop it up to here. We can still utilize direct modeling commands, these designer direct modeling commands. So I will pick this face as an extrusion face and this face as I'll just delete this one. This face as an extrusion face, and as an extrusion method, I will pick by entity, and I will select this face. So this helped me closing that gap. And now also maybe move this arrow closer here, as well as this face here, and that helped me create new iteration of this model. Obviously, we can stretch those inner faces as well if we want to, but that's the whole concept. We can apply unfolding view, so we have a nice modified model